structural provisions of our building codes. The first thing I thought I should mention is that the we when, to talk about structural changes in the structural provisions in our codes, it is important to point out that the structural provisions of the IBC, which forms the basis of all legal codes now, come from ASCE 7. They are mostly not even reproduced in the IBC. So there are big changes in the structural provisions of the IBC only when the referenced ASCE 7 edition changes. So 2006 and 2009 IBC referenced ASCE 705 as you all know. The 2009 the 2012 and the 2015 IBC referenced ASCE 710. So when we went in 2012 IBC from ASCE 705 to ASCE 710, there were big changes in the structural provisions of the IBC. Similarly, in 2018 IBC, which you may or may not have become familiar with yet, is based on ASCE 716. So between 2015 and 2018 IBC, there are very significant structural changes, which are really changes between ASCE 710 and ASCE 716. Now today I will talk about changes in the wind load provisions of ASCE 7 and followed tomorrow by changes in the seismic design provisions also of ASCE 7. I decided to start with pretty basic material. I will try to go through this part quickly, but I did want to give you kind of a full package. I think that would be that would make a lot of sense. So wind loading is the effect of the atmosphere passing by a stationary structure attached to the structure surface. What we are saying is that any structure you put up is in the way of wind flow. And this is why wind exerts a pressure on the structure, which we have to consider in its design. Wind loads are controlled by atmospheric and aerodynamic effects. Aerodynamic has to do with the structure itself. Atmospheric obviously is independent of the structure. The three terms in the general equation for wind, which I'm sure you are all familiar with, P, pressure, equal to velocity pressure Q times the gust effect factor G and the external pressure coefficient C sub P. Out of the three factors, the velocity pressure Q depends only on atmospheric effects. It does not depend on the structure. C sub P depends totally on the aerodynamics of the structure, and G is it depends on a combination of the two. It depends partly on atmospheric factors, partly on the aerodynamics of the structure. When we talk about atmospheric effects, it includes meteorological effects and boundary layer effects. The meteorological effects, meteorology provides a description and explanation of the basic features of atmospheric flows, and within that, climatology deals with the prediction of storm conditions at a given geographic location. So this is atmospheric flows, like we have this polar vortex now coming our way, and climatology deals, as we say, with the prediction of storm conditions at a given geographic location. Under climatological effects, we are concerned with thunderstorms, tornadoes, hurricanes, special regional wind effects. So when we design a structure, we have to be concerned about all of these wind related activities, thunderstorms, tornadoes, hurricanes, and special regional effects as far as wind is concerned.